So the second part of 7.2, or the second video, is really going to go on with the y equaling mx plus b, and occasionally utilizing that m equals y2 minus y1 all over x2 minus x1. Those are your tools in your tool basket. And really, I deviate from the textbook a little bit here in that the textbook uses a different form of the line. And so the textbook uses the point slope form, and I'm going to stay with mx plus b because I feel like if we've got a third tool in the tool basket, then we need to learn how to use that one. And we're going to stay with the 2 because I think that that is enough to cover our understanding. So we're going to carry on with 7.2 in figuring out equations of a line when we're given various pieces of information. So we're given some key information and we're going to figure out the equation of the line. The equation of the line always has a y and it has an x in it, but then we're going to be able to figure out the m value and we're going to be able to figure out the b value. So these have to be determined in the question. How we're going to do the determination of these lines, how we're going to figure out these, is with our information that we have already. So we're going to use this mx plus b form, and we're going to determine the m value. And if we have some point for x and y, that would be these ones over here. So we have an x and a y, then all we're missing is the b value. And so we're going to solve for b and then rewrite the equation in this, kind of open form or generic form. We go back to the y and the x as placeholders because they could actually be an infinite number of ordered pairs, putting those determined numbers back in. So that was a lot of words. I think show me, don't tell me is always a good way to go. With these ones, the key bit that we're dealing with is y equaling mx plus b is my framework. And we're going to list all of the information that we have. So in this one, it says determine the equation of a line with these pieces of information. So m is 3 over 2. My x value is a -2. My y value is a 4. What I don't have in my framework equation is the b. So what I'm going to use is my framework, and I'm going to sub everything I have in. So y equaling mx plus b is my framework, and I'm going to take everything that I have over here to sub in there. So my y is 4, my m is 3/2, my x is -2, and the b was my question mark. That's what I didn't know. That's what I'm trying to solve for, because if I have the m and I have the b, I have everything I need to give the equation of the line. So doing the math on this, I'd have 4 equaling -3, be -6 divided by 2 is a -3, or you could cancel them out, however you want to think of it, plus b. Solving for b, I would add 3 to both sides, and I get that 7 equals b, or b equals 7, which is fantastic information. It's a fantastic work, but we're not done. If we need to give the equation of the line, my final answer would be y equals m, because again, those are the key, that's one of the key bits, and an x, because those y and x's are just like placeholders. We've got an infinite number of ordered pairs, plus 7. So all of that work to get to the equation of the line that has the slope of this and runs through that point. Let's do b down below here because the other ones are a little bit weird. So b down below, this one says that I've got an m of 2, I've got an x of 3, and a y of 1. That's the information that's given to me in that ordered pair. So I've got an x of 3 and a y of 1. Again, what I don't have is my b value. So I'm going to use the framework equation that I hopefully have, I have grown to love. I don't know if you have. And I'm going to take everything that I know and sub into it. So I'd have 1 where I see the y, equaling 2 where I see the m, and 3 where I see the x, plus b. I'd have 1 equaling 6 plus b. Solving for b, I'd subtract 6 from both sides, so I'd get -5 equals b. And with that b piece of information, we already had the m, I can write the equation of my line. Y would equal 2x minus 5. Remember that the m and the b values are fixed, and we leave the y and the x open because they're actually an infinite number of ordered pairs that would lay on that line or be on that line. Okay, another one down below before things get weird over on the other side of the page. Again, we've got some pieces of information. I've got an m value, I've got an x value, I've got a y value. I don't know my b value. I'm going to use my y equaling mx plus b and sub everything that I can into it because what I'm trying to do is solve for b here. So I'd have 3 equals negative 2 times 0 plus b. I'd have that b equals 3. So this one, if I give the equation of the line, it'd be y equals negative 2x plus 3. That one actually had a shortcut in it, but oftentimes I think that people don't always see them. And it's okay if you don't see them because what I'm trying to do is give you a strategy. This is the y-intercept. We could have gone direct from here to that b term, but I think that it's important to have a process that you understand how you can solve for b. So top of the next column here, they get weird at the end. So in these ones, I've got a slope of 1, so that's m is 1. And I've got this weird bit of x and y. Again, with these, I'm going to use my strategy as much as I can. If you can see through to the equation of the line, then go for it. But if you don't, then I think we need a bit of a strategy. So I've brainstormed, I've pulled together all the information that I have. And again, what I'm missing is the b value. So I write down my framework equation. I'm going to sub everything in that I have for that. Whole lot of zeros. And I end up with b equaling 0. So the equation of my line is y equals 1m plus 0, or sorry, 1x, why did I do that? Plus 0, or get ready for this, all of this invisible stuff, the real equation of the line would be y equaling x. Oddball, because of how many things could technically be invisible, right? This 1 could be invisible on the x, and the 0 could also be invisible. The last two, hopefully you're starting to anticipate the oddballs. I always make sure that I roll them into every single new thing that we learn. And so this one says that the slope is 0. As soon as you see that the slope is 0 on something, there should be some alarm bells going off. The 0 slope was for the horizontal lines. There is a point of 2 and 3, so over 2 and up 3, that the line goes through. So the line is going to be actually horizontal through that line. If I want to try and do this as much as I can with that same strategy, this one's going to work okay, but not be super fantastic. So let's try it. We've got m being 0, x is 2, y is 3, and b is my question mark. So I'd have y equaling mx plus b, what I'm going to try and fit it into. I'd have 3 equaling 0 times 2 plus b. I get that b equals 3. So putting this back into y equaling 0x plus 3, this time we have something else that could be considered invisible. All of this could be considered invisible. And the framework of the equation, or the equation would finally look like y equals 3. I didn't do it when we did this here, but if you can take a look, it would be passing through y equaling 3 all the way along. We know that horizontal lines had that format of their equation of y equaling something. And in this case, that y equals a 3. So we've got the conceptual that is really good for backing up our strategies. With a horizontal line, it still fits the strategies that we've been developing. For the next one, it's not going to fit so well. So the next one says that our slope is undefined. So as soon as I see an undefined slope, I should think back conceptually. That's going to be a vertical line, and it's going to run through the point 2 and 1. So it'd be over 2 and up 1. So I'd have a vertical line at that point. If I go about, brainstorming everything that I've got so far, this whole fact that M is undefined, I can't sub that in. And so I'm stuck in the world of understanding this conceptually. When I went through this one, conceptually, I would say that X equals something for a vertical line. We've already got through the fact that it had an undefined slope. Here, the X is always stuck at 2, right? It's going to be a line at 2. So really the best you can do, rather than having a big old sub-in party, because you couldn't with this, is just go back to the conceptual understanding and give the equational line that X equals 2, because that's all it would be. So the next part is going to further use some of the information that we've been dealing with. We had these two key pieces of information. We know our slope equation and we know our slope-intercept form of a line equation. And really what we're going to do with these is use those two pieces of information. For these questions, we've got a line that runs through these 2 points, and it says, what is the equation of the line? So the first thing we're going to do is calculate our slope from this. If we can calculate our slope, we're on our way to figuring out the equation of the line. So with this one, I'd have x1 and y1, x2 and y2. So I'd have m equaling 7 minus 4 all over 4 minus 2. I'd have a slope of 3 over 2. The next thing that I would do to make this more like the questions that I've done before, I'm trying to gather enough information to sub into my framework equation. In this one, I have an x and a y given to me. I actually have multiple x's and multiple y's given to me. What I'm going to do is choose one of the 2 points here to be my x's and y's. So when I take this one, I just choose one of the 2 points. I happen to pick the smallest numbers and say that x is going to be 2 and y is going to be 4, so that I have everything I need to sub in and solve for b. You could get the same equation of the line using the other point. So this is the same information. It's the same format of what we were doing in those earlier questions. So I'm going to sub everything that I know in. So 4 equals 3 halves times 2 plus b. Remember, b is my question mark. That's what I don't know. I'd have 4 equaling 3 plus b. That's how I think of it. The 2's cancel. Subtract 3 on both sides, and I get that b equals 1, or 1 equals b. So putting this back into the equation line, that's what we're trying to do, is coming up with the equation of the line that runs through these 2 points. I'd have y equals 3 halves x plus 1. Remembering that my m and my b are fixed, and I leave the y and the x open for the infinite number of ordered pairs that would actually lay on that line. Let's do another one, and I'll try and keep paralleling these ones, no joke in that, to try and make you see how they really are a lot the same. So we're given another bit of information, and essentially what they're saying is, if a line goes through these 2 points, what's the equation of the line? And so in the other ones, the first ones we did, we were given the slope. In these ones, we're given enough information to calculate the slope. So we'd have 4 minus 2 all over 6 minus 3. I'd get a slope of 2 over 3 for this one. Once I have that slope of 2 over 3, I'm going to keep trying to get all the information so that I can sub in and solve for b. Similar to the last question, what I'm going to do is choose one of my 2 points to be the x and the y. And so I'm going to keep filling in this list here. So my x would be a 3, my y would be a 2. And what I'm going to do is sub into my awesome y equals mx plus b equation to solve for b. So I'd have a 2 in the place of the y. My m is 2/3. My x is 3. And my b is what I don't know. When I solve for this, I get that 0 equals b or b equals 0. So now I have enough information, those two key fixed pieces of information being m and b, so that I can write the equation of the line. So y would equal 2/3 x plus 0. And you can put the plus 0 on there, or you can leave it off because it would be invisible. Last one on the page, a couple more like this to try. They're similar. I've got enough information to calculate my slope. So it'd be -2 minus -2 for my change in y. I'd have 3 minus 7 for my change in x. I can clean this up a little bit. I'd have 0 divided by 4. Remember that that is on. You can try it on your calculator. Knowing which is a 0 and which is undefined is critical. My m is 0 here. Again, what I'm going to do with these is I can pick either of my points. I'm actually going to pick these two because they happen to be smaller, right? Those 2 points, or sorry, values are what's going to give me the information to use as an x and a y. One more time, what I don't have is a b term. Now, as soon as I see that my slope is 0, I could think of this conceptually. So I know that I've got a horizontal line. I could even graph these 2 points on the graph to kind of conceptualize what the heck is going on. Or I can kind of rely on this y equaling mx plus b. So let's sub in and keep going with this strategy. As always, if you can see through to the answer, that's fantastic. But if you can't, you need a way to get there. So that's subbing everything in and again, solving for b so that we can kind of parallel these. I get that b equals a -2. So putting it back together, I'd have that y equals 0x minus 2, or just that y equals a -2. And that should fit whether you got there conceptually or with this big old sub-in party for mx plus b. Those horizontal lines work. Any guesses on what the last example is? If you said vertical line, you are right. So in this one, if I take a look at it, I could take and go about it in the same way. So I've got, oops, I did that again. X1 and or X2 and Y2. I'm going to sub in and solve for the slope. And when I do that, I get that m, or my slope, would equal 8/0. If you put that in your calculator, it would say error. In math, we say that my slope is undefined. Pretty hard to sub an undefined value into your equation, so this is where you get stuck thinking of it conceptually. You could just graph these 2 points if you wanted to. So 4 and -5 would be somewhere down here, and 4 and 3 will be somewhere there. So your line would look like this. It is a vertical line at x equaling 3. And so x equaling 3 is just the equation of the line. You can't rely on that like big sub-in party and solving for b. In this case, it's much better to go with it conceptually. So one more kind with these ones. So these ones give you, again, pieces of information and then say, okay, well, what's the equation of the line? So these ones have some information about an old line, but it's asking you about the new line. So this question here, I'm not going to read through the instructions, you can go back to it. So it says, find the equation of the line that is parallel to this line. This would be the old line, or line 1 if you want to do it that way, and running through this point, and that point is on line 2. So my new line is line 2. So what I need, same as I had before, is I would really love an m, an x, a y, and solve for the b value, right? This is always kind of my key to try and determine so that I can come up with a way of subbing into mx plus b form and solving for b. So my old line, I need to figure out the slope because I know that my slope is going to be the same as my new line. It says the two lines are parallel to each other. So the old line is this, and the quickest way for me to see what the slope of that line is to put it into mx plus b form. So we'd start by subtracting 3x from both sides, and I get that 4y equals negative 3x plus 12. Divide by 4 everywhere, and I'd get that y equals a negative 3/4 x plus 3. So the key bit here is that I can see the slope of my old line. I know that it's exactly the same slope if it's parallel, and so the slope of my new line, or the line that goes through this point, is negative 3/4. This point on the second line gives me my x value and my y value. So now I can see that it's the same as the way I've been doing these before. I've got everything but the b value to sub in, and then I can solve for b. So I get the next line being 3. So not satisfying when I get a 0 somehow. So 0 equals b. And from all this, that final leap of logic, the whole idea is that we're supposed to find the equation of the new line, right? So the equation of the line is y equals negative 3/4 x, because we know that our m value is fixed and our b value is fixed. It's a plus 0, so you can just leave it off if you like. Another one, again, pieces of information, a bit of a riddle. The whole idea is we're supposed to come up with the equational line that the question's talking about. So it says find the equational line that is parallel to this line and running through that point. So this would be line 1 and this is line 2. And the two lines are parallel to each other. So I'm going to start with line 1, which is this equation. And I'm going to put it in mx plus b so I can figure out what the heck the slope is of it. So I'd minus 3x from both sides. I get negative y equaling negative 3x plus 2. I haven't solved it for y yet. I need to divide by negative 1 everywhere to finally get that y equals 3x minus 2. The whole idea in this is that I was trying to do this so that I could figure out the slope of this one line. I'm going to try and kind of bring that over. I know that my slope of my line 2 is going to be exactly the same because it is parallel to that. So my slope for the line 2, the one that I'm being asked about, is 3. I've got an x value of 2 from my ordered pair. I've got a y value of negative 1, and as usual, I don't know what my b value is. So in order to figure out my b value so I can give the equation of the line, I'd start with my framework equation, sub in everything that I can, and solve for b. Once I have what b is, now I can give the equation of the line. We know that my slope is fixed and my intercept is fixed, but the y and the x are placeholders. So that's the equation of the line the question is asking about. Two more questions to work through with this one. It usually takes a little bit to kind of catch the hang of these, mostly in just reading the question. So it says, find the equation of the line that is perpendicular to this line and passes through this point. So this information is about line 1. This information is about line 2. And we know that the lines are perpendicular to each other. So we're going to start with information about line 1, or the equation of line 1, because that's how we're going to get our first piece of information. We're going to try and determine the slope of line 1, because then we know that the slope of line 2 is perpendicular to that. So that's that upside down opposite. So starting with the equation for line 1, I'm going to put it in slope-intercept form so that I can figure out what the slope is. Negative 5y equaling negative 2x plus 10. Divide both sides by negative 5 so that I have y equals 2/5 x minus 2. Now that I have this, why I did that was so that I could see what this slope is here. If my other line is perpendicular to that slope, that's the upside down negative of that number. So my slope of my new line would be negative 5 over 2. Again, I'm going to go to that information from the question. I had an ordered pair that was part of my other line. So I have an x and a y value given in that. So I keep listing everything that I have. And as per usual, I don't know what b is. I go back to my favorite format of a line and sub everything that I can in. This one's a bit uglier. Just going to switch colors there. Hopefully keep you with me on the fraction math. My next line would be 5 equals negative 10 plus b. Solving for b, I'd add 10 to both sides, and I get that b equals 15. So putting it all back together, going back and remembering why I'm doing this, I have my fixed m term and my fixed b term. That's the key bits that help me build that equation of the line. So y and x would be placeholders. My m is one of those fixed things, the x again a placeholder, and the b being plus 15 needs to be in there. So that's the equation of the line that this question is talking about. One more, congratulations if you're still with me on this. This one's similar to the last one. So it says find the equation of the line. We know that the line we're being asked about is perpendicular to this one. So this is line 1 and it's going to be perpendicular to line 2. And this point is line 2. So that gives me an x and a y value. Again, what I'm doing with line 1 is putting it in slope-intercept form so I can see what the slope is. Here I can see that my slope, or my m value, negative 4. So my line 2, if it is perpendicular to that, my slope for my new line is 1 over 4. Remember, it's the negative upside down version of that slope when it's a perpendicular line. My x is going to be 4, my y is going to be 3, and the b is what I don't know. I go back to y equaling mx plus b because it's awesome, and I sub everything that I know into it to solve for b. I get that b equals 2, and if you're still with us on that, the whole point here is that that 1/4 and that 2 are key because that really is what we need to write the equation of the line. We'd have that y equals 1/4 x plus 2 as the equation of the line. We are not doing 7.3 in your textbook. It's not an articulated outcome, so we'll be doing 7.4 next.